Hello, dear viewers. Welcome to TV Matter. In our today's session, we shall be looking at question 15 for Pure Mathematics 2025. Remember that we have already looked at the solutions for the questions from 1 up to 14. And in case you haven't watched the video for these questions, please do so. Check our previous videos or check in the playlist for UACE Pure Mathematics and Applied Mathematics 2025. You'll be able to get other solutions. Or else, find the links to these questions in the description for this video. So let us look at question 15. Question 15 has two parts, A and B. So we shall start with part A, which says, without using mathematical tables or a calculator, show that cos inverse of 8 over 17 plus sine inverse of 4 over 5 is equal to tan inverse of this. So we shall look at the solution. So looking at the solution, one, we shall first of all relate alpha to represent cos inverse of 8 divided by 17. Then we shall also let beta to represent this. When we let alpha to represent that, it means that cos of alpha, it implies that cos of alpha is same as having 8 over 17. Likewise, we shall also let beta to represent a sine inverse of 4 over 5. And when we do so, it means sine of beta is equal to 4 divided by 5. Now, when you look at what basically we are having that cos inverse of this plus sine inverse of this is equal to that. So we shall call this equation star because we shall be referring to it. So from a star, from equation star, it means that we have alpha plus beta, which is equal to tan inverse of negative 77 over 36. So from here, we shall introduce tan on both sides. So we shall have a tan of alpha plus beta is actually same as tan of tan inverse of negative 77 over 36. So it means our interest is to show that tan alpha plus beta is equal to negative 76 over 36. So this is our main target. So we need to show that tan of alpha plus beta is equal to that. So this is what we need to show. So we need to show that tan of alpha plus beta is equal to negative 77 over 36. So we shall therefore consider, let us consider tan the left hand side. So we shall consider tan of alpha plus beta. So tan of alpha plus beta is same as having tan of alpha plus tan of beta divided by 1 minus tan alpha tan of beta. So let us now look at how best we can get tan of alpha and tan of beta. So we know, or we are given, we already know this. So we know from cos of alpha, which is same as 8 over 17, we can easily draw a right angle triangle here and have this as 90 degrees and have this as alpha. So when this is alpha, cos of alpha, cos is adjacent, which is 8 over hypotenuse, which is 17. So this is the opposite. So opposite squared plus 8 squared is equal to 17 squared. So which means that opposite squared, will be equal to 17 squared minus 8 squared. So 17 squared minus 8 squared will give us 225. So take square root and get your opposite as the square root of 225, which is 15. So it means this side is 15. So if that side is 15, so we can get tan of alpha. So we shall go on and get tan of alpha. So what will be tan of alpha? So from this given point, tan of alpha will be same as opposite over adjacent. So the opposite is 15, adjacent is 8. So from this same triangle, so we are able to get tan of alpha. So we shall go on and get tan of beta by also considering, let us now also consider that we already have that sine of beta is the same as, we already have that sine of beta is the same as a sine of beta is here, is 4/5. So sine beta is 4/5. So we have 4 divided by 5. So this represents sine is opposite over hypotenuse. So it means we can again draw a right angle triangle here. So sine, if this is our angle beta, so the opposite is 4, the hypotenuse is 5. So we need the adjacent. So we shall also use the Pythagorean identity to get A. So A squared plus 4 squared is equal to 5 squared. And this gives us A squared as 5 squared minus 4 squared. So 5 squared minus 4 squared will give us 9, which means that our A is actually same as 3. So this is it, a 3. So from here we can get tan of beta, and the tan of beta will be opposite, which is 4, over adjacent, which is 3. So we have got tan of alpha and we have got tan of beta. So for that case, let us refer again to this given expression. Let us call this one equation number 3. So from equation number 3, so we shall have from equation 3, we shall have from equation number 3, which says that tan, we need tan of alpha plus beta, but we are saying this is same as tan alpha plus tan beta divided by 1 minus tan alpha tan beta is divided by that. So this will be able to give us tan alpha is 15/8 and beta is 4/3. We are dividing this 1 minus 15/8 times 4/3. So this will give us, so get the LCM here. So that will be 8 and 3. So basically let us get 15 divided by 8 plus 4 divided by 3. So that will give us 77 divided by 24. So we shall subtract, let us get 1 minus. So this is by 4 is 1, by 4 is 2, by 3 is 1, by 3 is 5. So we shall have 5 by 2. So this is 1 minus 5 by 2. 1 minus 5 by 2. So 1 minus 5 divided by 2 will be able to give us 1 minus 5 divided by 2. So this will give us 77/24 divided by -3/2. So from here we shall be able to simplify this. So let us go on and try to simplify this. This is same as 77/24. We are dividing this by -3/2. So this will give us, so we are having 77/24 times the reciprocal, that will be -2/3. So let us try to simplify this. So by 2 is 1, by 2 is 12. So we shall get 77/12 times 3. This is a minus. 12 times 3 is 36. So therefore a tan, and therefore say tan so therefore we can easily see that we have got our tan of alpha plus beta as -77/36. So this implies that alpha plus beta is actually same as tan inverse of -77/36. And from this, you already know that your alpha is this. You already know that your alpha is cos inverse of that. You already know that your beta is sine inverse of that. So when we place them back, it means that this will imply that cos inverse of 8/17 plus sine inverse, which is representing beta, sine inverse of 4 over 5 will be equal to tan inverse of negative 77 over 36. And that is what has been required. So this is the required expression. So it means this part here, which is part A, will be answered. So 15 part A will be answered. So let us look at now part B. So looking at part B says that you are given so we have that we need to solve the equation 2 cos of x plus sec of x is equal to 3 for 0 degrees less or equal to x less or equal to 90 degrees. So let us look at the solution. So from what is we are given that 2 cos of x plus sec of x is equal to 3. So we know that sec of x is 1 over cos, so we can get our expression purely in terms of cos. So we shall substitute for that. So 2 cos of x plus sec is 1 upon cos of x is actually equal to 3. So from this given point, we have 2. Let us multiply through by cos of x. So this will be 2 cos squared of x plus 1, which is equal to 3 cos of x. So this will give us 2 cos squared of x minus 3 cos of x, then plus 1, which will be equal to 0. So from here, you can let u to represent cos of x, such that you will have this as 2u squared minus 3u plus 1, which is equal to 0. So we need the factors of 2, which we add together to give us negative 3, and the product to remain 2. So that will be negative 2 and negative 1. So 2u squared minus 2u minus u plus 1 is equal to 0. So this is 2u into u minus 1. So here we shall open the same bracket, u minus 1, and we shall place here negative 1, and this is equal to 0. So from here we shall have 2u minus 1 into u minus 1, and this is equal to 0. So for that case, it implies that either 2u minus 1 is equal to 0, or u minus 1 is equal to 0. And this will give us 2u, which is equal to 1, and u will be a half. And likewise, u will be equal to 1. So from here, we have u as that. So we shall now consider each of the values of u at once. So consider u equaling to a half. Remember, u represents cos, so cos of x is equal to a half. And for that case, x will be a cos inverse of a half. So x will become, what is cos inverse of a half? So cos inverse of a half is a 60 degrees. So we shall have a 60 degrees. So from here we need to get other corresponding angles. If this is 60 degrees, cos is positive. Cos is positive in this quadrant. Cos is also positive in this quadrant. That is the first quadrant. When we name our, that is all, then sine here, tan here, then cos here. So it means this angle will be there. And again, we need to take this angle. This angle will be 300. That is 360 minus 60. But considering the range, it means 300 will be outside the range. So it means for this given point, the only value of x which will be satisfying will be 60 degrees. The other one will be outside the range. So next, we look at u equaling to 1. So when we look at u equaling to 1, so u equaling to 1, we shall have, let us talk about u equaling to 1. So when u is equal to 1, it will imply that so this will imply that cos of x is equal to 1. Then x will be cos inverse of 1. So x will be equal to cos inverse of 1. Cos is a positive 1 at 0 degrees and 3 at 60 degrees. So here cos is negative, that is 180 and negative 180. So x will be 0 degrees. The next angle which would be corresponding would be as 360 degrees, but considering the range, 360 will be out. So therefore, x will be equal to 0 degrees. So from there, let us list all the angles. So we shall say for 0 degrees, less or equal to x, less or equal to 90 degrees, less or equal to 90 degrees. The values of x that will be in that given range will be 0 degrees and 60 degrees. So from there, our part B will also be answered. So that is all about question number 15. So question number 15 will be answered and you'll be able to get your 12 marks. And lastly, let us look at question number 16. So it says sketch the region bounded by the curve, this one here, and the x-axis. So let us look at how best we can sketch this curve. So to sketch this curve, we shall first of all get the intercepts. So let us look at intercepts first. So we shall consider for y-intercept. And we know for y-intercept, x is equal to 0. So it means our y will be same as 2 plus 0 minus 0 squared, which is 2, giving us the point which is 0 and 2. And next we look at for x-intercept. We look at for x-intercept. This is where y is equal to 0. And if y is 0, it implies that we shall have 0, which is equal to 2 plus x minus x squared. So in other words, we shall have x squared minus x minus 2, which is equal to 0. So we need to solve this quadratic equation. So we need the factors of 2, which we can add together to give us -1, and when we multiply to get -2. So basically, that will be minus 2x, then and x, that is 1 and -2. When you add this together, you get -1. When you multiply them together, you get -2. So minus 2x, then plus x minus 2 will be equal to 0. So x into x minus 2, open the same bracket, x minus 2. So here we shall put +1 equal to 0. So here x plus 1 into x minus 2 will be equal to 0. So either x here will be equal to, either x will be equal to -1 or x will be equal to 2. So giving us the points -1, 0, then 2 and 0. So we have got what we call the intercept. So after getting the intercepts, we shall look at the turning points. So next we shall talk about the turning points. So for the turning points, the turning points occur at a point when dy dx is equal to 0. So turning points occur at a point where dy dx is equal to 0. So we shall get dy dx first. So from y, which is equal to 2 plus x minus x squared, dy dx will be same as, this is 0, differentiate this, 0, differentiate that is 1, differentiate this, minus 2x. So for the turning points, we are saying they occur at a point where dy dx is 0. And for that case, it means 1 minus 2x is equal to 0, giving us 2x equaling to 1, and x becomes a half. So giving us the value of x as a half. When you get the value of x, it is important to get the corresponding value for y. So for y, we shall get y, which is equal to 2 plus a half minus a half squared, that is a quarter. So this should be able to give us the corresponding value of y. So we have 2 plus a half minus, so this will give us y as 9/4, or which we can write as 2.25. So this is 2.25. So it means our turning point will be, so therefore the turning point will be our turning point will be a half and 2.25. a half and 2.25, which is 9/4. So this will be what we call the turning point. So after getting the turning point as that, then we shall go on and get what we call the nature of the turning point. So next we shall talk about nature of the turning point. So to get the nature of the turning point, we have two different ways of how we can do that. One is using the second derivative, and two is using the sign change. So we can refer to our first derivative, then we get the second derivative. So that is dy dx is 1 minus 2x. So we shall say from dy dx, which is equal to 1 minus 2x. So what will be the 2y dx squared? The 2y dx squared will be same as differentiating dy dx, which is 1 minus 2x. So this will give us minus 2. And we can easily see this minus 2 is actually less than 0. And if that is true, then it means our turning point, a half, 9/4, is a maximum point. Is a maximum point. So this will be the nature of our turning point. So next, after getting that, we can also look at where our curve is tending to. So as x tends to positive infinity, where is our y tending to? So remember, our y is given as, remember we have y as 2 plus x minus x squared. So if x is tending to positive infinity, if x is becoming a positive value, so you look at this x that has got the highest power. So when you put a positive value here, then your expression will still remain a negative. So this is tending to negative infinity. Then as x tends to negative infinity, then y will be tending to, when you put the value of x which is positive, this one x squared will always give you a positive value. So this value will be positive. But because of this minus, it means it will give us a minus answer. Then likewise, if this is negative, if x is negative, then x squared will be positive. But because of this minus, it will make it to also be minus. So this will also be tending to negative infinity. So from that, we can now draw our curve. So we shall first of all put our intercept. So we have got our intercepts here. Our intercepts, we have 0, 2. We have negative 1, 0. Then we also have 2 and 0. So we shall substitute for this in our diagram. So 0, 2. Let us have 0, 2. So if this is 0, then let us assume that our 2 will be there. So 0, 2 point is this one here. So this is our point 0, 2. This is our point 0, 2. Then next we have to put negative 1, 0. Point negative 1, 0. So let us have negative 1 here. So this point will be the point negative 1, 0. And next we shall put the point 2, 0. The point 2, 0. Let's assume our 2 is here. The point 2, 0 is this given point. So this is where we have a 2, 0. So we have our y, we have our x. So next we shall put our turning point. Our turning point is 0.5. This is same as 0.5 and 2.25. 0.5 and 2.25. So 0.5, if this is 0 and this is 2, so if 1 is like here, so 0.5 will be around here. So next we need 2.25. So let's assume that our 2.25 will be at this given point. So from here, we shall have this as 0.5 and 2.25. So from there we can draw. We are also having that if x is tending to positive infinity, y is going to negative infinity. In other words, if x is becoming positive, y is going to negative, and if x is going to negative infinity, y is going to negative still. So we shall have our curve in that direction. So this is a maximum point. So it means our curve should turn from this given point. So let us try to put our curve there. So this is where our curve will turn from. So it will turn from this given point. It passes through this intercept and it goes in that direction. It comes like that. It passes through this given point and it goes in that direction. So it means, according to what we are interested in, we need the region which is bounded by this and the x-axis. So that region which is bounded by the curve, so this is our curve, which is y equaling to 2 plus x minus x squared. So the area which is bounded by that is this area. Then part A will be answered. Now looking at part B, they are saying the region in A is rotated about the x-axis. Calculate the volume of the solid that is adjacent. So to look at the volume of the solid that is rotated, we are rotating this one here along the x-axis. So in other words, you'll be able to get, when you rotate, you'll be able to get something which is of this nature. So when this one is rotated along the x-axis. So what we shall do is to use what we call the disk method, and we know to get the volume, of this solid here, then what we can do, what we shall do here is to use the disk method, which says that V is same as pi integral from A to B of y squared dx. So A to B, we need those limits there. So these limits will be from, let us look at, this is from -1, the point of intersection between the curve and the x-axis. So that is -1 up to 2. So this will give us V as a pi integral from -1 to 2 of y. So our y is 2 plus x minus x squared, and the whole of this is squared, then dx. So our major now a major thing to do here is to first get this one here. So let us consider first 2 plus x minus x squared, and the whole of this is squared. So when we consider this, we can try to group this such that we have this as 2 plus x then minus of x squared, but the whole of this is squared. So I want to call this one A, I want to call this one B. So to expand this, we have a squared, 2 plus x squared, then minus 2ab, 2 into 2 plus x, then into b, which is x squared, then plus b squared. Remember, it is a squared. If you have a minus b squared, this will be same as a squared minus 2ab, then plus b squared. So that is what I'm using. So this will be plus x squared, again squared, which is x to power 4. So this can also be expanded to give us 4 plus 4x plus x squared. We can try to simplify this. This will be minus, when we get minus 2x squared times this will give us minus 4x squared. Then minus 2x squared times x squared will give us minus 2x to power 3. Then plus x to power 4. So in general, this will give us x to power 4 minus 2x to power 3. This and this will give us minus 3x squared plus 4x, then plus 4. So basically, that is what we shall have. So this is x to power 4 minus 2x to power 3 minus 3x squared plus 4x, then plus 4. So this is the expansion for this. So in other words, we shall have that our volume is same as pi, the integral from -1 to 1 of x to power 4 minus 2x cubed minus 3x squared plus 4x, then plus 4. This is into dx. So this will give us v, which is equal to pi. This is from -1 to 2. So let us try to integrate this. This is 1 over 5, x to power 5, 2x to power 4 over 4, minus 3x to power 3 over 3, plus 4x squared over 2, then plus 4x. The whole of this is from -1 to 2. So we can try to simplify what we have in the brackets first. So we can have this as v. This will be v, which is equal to pi into, so this will be 1 out of 5, x to power 5. Then this is minus 1 over 2, x to power 4, minus 1 over 2, x to power 4, then minus x to power 3, then plus 2x squared, then plus 4x from -1. So this is from -1 up to 2. So v will be equal to pi into, so let us first substitute 2. When we put 2, this will be 1 over 5 times 2 to power 5 minus 1 over 2, 2 to power 4 minus 2 to power 3, 2 times 2 to power 2 plus 4 times 2. So that is what we shall get. And from this given point, that is when we put at the upper limit. So let us put the lower limit, and the lower limit will be -1. So which means this will be 1 over 5. -1 to power 5 is -1, minus a half. -1 to power 4 is +1, minus -1 to power 3 is -1. Then plus 2 into -1 to power 2 is 1, then plus 4 into -1. So the whole of this is into pi. So this would be same as pi into, so this is 32 over 5 minus, this is 8, this is also 8, this is also 8, then again plus 8. Then we are subtracting, this is -1 over 5, this is minus a half, this is plus 1, this is plus 2 minus 4. So this will give us pi into, so this 8 will be able to cancel out, will remain with 32 over 5 minus, so let us try to simplify what we have in this bracket. So this will give us, this one in the brackets here will be able to give us a negative 17 over 10. So from there we shall have this as pi into, so we have 32 over 5 plus 17 over 10. So from there we shall be able to get the v, which will be pi, then times pi times, so we get, we try to simplify this. We have 32 over 5 and we are adding there 17 over 10, and this will give us 81 over 10. So this will give us 81 over 10. So from here we can therefore say v is same as 81 over 10 pi cubic units. So that is the required value for the volume. So the volume of the solid generated will be that. So the volume of the solid generated, therefore the volume of the solid generated is 81 over 10 pi cubic units, and that will be the required answer for 16 part B. So from here we shall have looked at all the questions for pure mathematics from question number 1 up to question number 16. Please, if you find this video helpful, don't forget to subscribe to this channel, like and share to your friends. So that's all for pure mathematics.
Yeah.